Alright, so in this video we're going to talk about solving three variable systems, okay? And when we're solving three variable systems, I have to stress it's extremely important that we stay organized and stay very neat, because it's very easy to make a simple little sign mistake or just write something a little bit messy to where we incorrectly do a particular step and then our entire problem is blown up. Okay, so with three variable systems we need to be very clear, concise, and neat and stay organized. Okay, now we have a three variable system right here. Okay, we have negative 5x minus 2y plus 2z is equal to 17, negative 4x plus 6y plus 2z is equal to 30, and 3x plus 5y minus 2z is equal to negative 5. Okay, now, when we're solving three variable systems, the preferred method that I use is actually elimination. Okay, we're going to use a lot of elimination today. You could use substitution, but I'm going to go ahead and do elimination. Now, when we solve three variable systems using elimination, what we need to do is kind of pick on a single variable and eliminate that variable twice using two different sets of equations. Okay, so in this particular system, it looks like it's going to be fairly easy to cancel out the z's, to eliminate the z's, okay, because I have a positive 2z, and a negative 2z. So I'm going to go ahead and focus on canceling out the z's. So I'm actually going to go ahead and add the first two equations together. So I'm just going to go ahead and rewrite this to stay organized. Or excuse me, the first and last equation. I'm going to add the first and last equation together. So there's my first equation, and here is my last equation. And I'm going to add these two together, because when I add these two together, the z's are going to cancel. So negative 5x plus 3x is a negative 2x. Negative 2y plus 3y is a positive 3y. 2z minus 2z, those eliminate. That's what we want. So those are 0 is equal to 17 minus 5 is 12. Okay, so this is a new equation. We're going to be coming back to this equation in a little bit. Okay. So now notice I use the first and third equation to cancel out z. Now I need to use a different combinations of equations and cancel out z once again. Okay, so in this case, I'm actually going to use the second and third equation. So I'm going to go ahead and rewrite this just to be safe. So negative 4x plus 6y plus 2z is equal to 30, and 3x plus 5y minus 2z is equal to negative 5. Okay, and now when I add these two particular equations together, the z's are once again going to cancel. So I'm going to get a negative x, negative 4x plus 3x is negative x, 6y plus 5y is 11y, 2z minus 2z cancel, that's what we want, and is equal to 30 minus 5 is 25. So these are new two equations. And the reason we did this is now if you look, I'm going to go ahead and rewrite these on top of one another. I now have a two variable system, and this is something that we've done straight from Algebra 1. Okay, now I just have a pretty straightforward two variable system, and I can solve this two variable system using substitution or elimination. It really doesn't matter. Okay, but I'm going to go ahead and keep using elimination. So I'm going to go ahead and cancel out the x's, because the x's look like it's going to be a little bit easier to cancel. So I have I have a negative 2x up here. I'm going to want this to become a positive 2x. So what I'm going to do is I'm going to multiply this equation here by negative 2. I'm going to multiply this equation by negative 2. So now I'm going to have, and I'm just going to rewrite it real quick, negative 2x plus 3y is equal to 12. And I'm multiplying the second equation through by negative 2, so I'm going to have a positive 2x minus 22y is equal to negative 50. And I did this because now when I add these two equations together, the x's cancel. Negative 2x plus 2x cancel. 3y minus 22y is negative 19y is equal to 12 minus 50 is negative 38. And the reason we want to do this is now I just have an equation with just y, so I can divide each side by negative 19, and that's going to get us y is equal to 2. Okay, so I got y is equal to 2, and that's actually the hard part. The hard part is solving for your first variable. After that, it's a lot easier. Okay, because remember, a solution to a system is where the graphs intersect. In this particular case, since it's three variables, this is in 3 dimensions. So instead of having an ordered pair as our answer, we're going to have an ordered triple. Okay, this is going to be a point in 3-dimensional space. Okay, so y is 2. That's one of our 3 variables. Now we got to go ahead and find the other 2. Well, I can kind of quickly find that. By plugging 2 into either of these 2 equations for y. I'm going to go ahead and plug it in for y in this equation. Now I want to use one of these 2 because if I plug it into one of the original 3, I still only know one of the 3 variables, so that I'm not going to be able to solve for either of them right away. But in these 2 equations, I have it in just terms x and y, and I know what y is, which means I can quickly solve for x. So let's go ahead and do that. So if I plug in 2 for y into this equation, I'm going to have negative x plus 11y, and y I found out is 2, is equal to 25. And now I get negative x plus 22 is equal to 25. I can subtract 22 from each side to get negative x is equal to 3. And now that's just a negative 1 multiplying x, so I can divide each side by negative 1. And I get x is equal to negative 3. So now I have x, I have y, all that is left is to find z. So now I can take x, I can take y, and substitute it into any of these 3 original equations. Okay, I can substitute them into any of the 3 original equations. So what I'm going to do is I'm going to actually plug both of these into the 3rd equation. So I'm going to plug in 2 for y, and I'm plugging negative 3 for x. Okay, I'm plugging negative 3 for x because I went ahead and found that x is negative 3. So we're going to have, I'm going to write it over here, 3x, and x is negative 3 plus 5y, and y is 2 minus 2z, that's the only one I don't know anymore, is equal to negative 5. And now I can just go ahead and simplify this and solve for z. So I'm going to have negative 9 plus 10 minus 2z is equal to negative 5. So it's going to become 1 minus 2z is equal to negative 5. I can subtract 1 from each side to get negative 2z is equal to negative 6. And now divide each side by negative 2. Now divide each side by negative 2 to get z is equal to 3. Okay, so now I have all 3 of my variables, so now I can go ahead and write my final answer. So x was negative 3, y was positive 2, and z was positive 3. So this point here would be my solution to this 3-variable equation. Okay, so that was just one example. As you can see, it takes a little bit of work. It's really easy to make a small mistake and have your whole problem suffer because of it. So make sure we're being very, very careful and neat with all of our work. Okay, and I do recommend maybe using different colors when we're getting our 2 new equations so you can kind of see exactly what you're working with. Okay, so I'm going to go ahead and make another video. We'll do one more problem, maybe even 2, but just one, but at least one more problem of solving 3-variable systems. So you can check that out in the next video.